In today's video, we will take a look at the problem fence rails. So here we have a few boards and we want to find the maximum number of rails that we can cut using these boards. So we can basically use binary search in this problem, and every time we use binary search, we will implement this check function to check the total number of boards that we can get. So here we'll first reading the boards and then reading the rails. So this rail keep track of how much rail of this length x are there. So every time we're reading an x, we increase this count. And then here I will sort the board lengths according to their from smallest to largest, because this way we'll use a greedy solution to search through the possible combinations. So this is the main part is still the same thing as a basic binary search, and here the different special part is this check function. So this check function will reading three parameters. The first one will reading the current length of the rails that we're looking at, and this p will represent the board that we're looking at. So it will tell us which board we're looking at, and this waste will keep track of the boards that we didn't use. So we can, for example, maybe we have a board that has a length of 11 and we have two rails with length 5 each. So then the waste will be 1, and then we'll add up the waste for each of these boards every time we look at them. So here we'll use recursion. We can try to see all of the rails that are smaller than this current rail, or smaller than or equal to. We don't have to look at the ones that are greater, because we would have already searched through those greater ones when we were going down this recursion. And I chose to start at the biggest and go down to the smallest, because this way we can always take away as much of the current board as possible. So basically using this greedy method, this will help us stop this program earlier. So there are a few base cases, and every time I use this binary search basically represents the length, the total number of rails that we can get. So we test if it's possible to get this middle amount of rails. And to get the middle amount of rails, you add up the two, then divide by 2, so basically get the middle of these two, left and right. And every time we have to reset our current statistics. So first of all, we will have to change our board length to the original board length again, because here we would have taken away a few of these boards when we are cutting them into the different rails. So here I'll reset the boards into our original board, and also clear this count. So this count keeps track of how many rails there are. So after we reset, I will use this to go through all of the possible rails. And so the largest rail only has a length of 128, so we can loop through each of those, and then just add those up into our CNT. So basically our temporary rail. And here we'll only look at the first few middle. So we'll look at the first few rails that are smaller than this middle length. So only look at that much rail, and then we can see if it's possible for us to obtain these rails from our board. So here in this function, we would first check a few things. Will check if our current waste is already greater than the maximum waste that we can get. And the maximum waste that we can get is just the sum of our total board. So the total length that we have in our board subtracted by the total sum of the rails that we're currently looking forward, that we're wanting to get. So that'll be the maximum that we can. That will be the maximum number of waste that we can get. If it's greater than that, this means that there will be no ways for us to form those rails using these current combinations, so we will return false. Otherwise, if we've searched through all of the boards and our waist is still smaller than or equal to the max, then I will return 1, meaning that this is possible. And then here I will check for each of these rails that we have, and here we will look at the ones that are only smaller than the current rail, and we check if a rail of this length I exists. If it exists, we have to make sure that it's smaller than the current board, so we can subtract it away from the current board, basically cutting this board, so then we will have this piece with length I. So I will decrease the count for this I by 1, meaning that we already formed a rail using this board, and we'll subtract this I from the board. And now we check this again, but here our P is still the same. We're still looking at the same board, and our waist didn't change yet because it's still the same board. We haven't decided what is the final waist that we have on this board, but here this current length should be changed to I. So later on we will only search through the boards that are smaller than this current I. So we check if it's possible for us to get this many rails using these. If we take away this rail from this board, if it is possible, we could return 1 and stop this recursion right away, because it's already a possible way. We don't have to look at any other possible ways. Otherwise, we will restore these values and try the next rail. So here we increase these by 1 and also increase the board length by I again. So basically make it seem as if nothing has happened. And then finally, we will look at the next board, so P plus 1. And here I will change the current length to 128 because that is the maximum. This way in the next board, we will still look at all of the rails that we currently have. And the waist will just be the current waist added to the current length of this board, because we didn't use this much of the board. Since if we already used those, we would have subtracted it away already. So this will be the remainings of this current board, and we add that on and use this recursion again. So this will keep on going until we've reached either 0 or 1. And then, so here I'll also start at 128 because we're looking at all of the rails that we have. And then we're looking at the first board, so board 0. Also, the waist should be 0 right now because we didn't find any waist yet. And we check if it is possible to form this middle amount of rails using all of our boards. If it is possible, then I will change our left to this middle amount. So next time we will look at something greater than this current middle amount. Otherwise, I will change our R to middle amount minus 1. So the next time we will look at something that's less than this current middle amount. We will keep on going left and right until we reach until we reach another middle amount that can be reached by this many amount of boards. And every time here, I will use this current C to add up to keep track of the total number of rails that we've already added. So we don't want to add more than the total amount of this middle length, because here we're only looking at the first mid. We're only looking at the first mid rails. So here I'll use the CNT to keep track of the total rails for this current situation, and it will be added to the minimum rail amounts that we have for this current length, or the middle minus C. So C is the current number of rails that we've already added on. So we should get the minimum of these ones to make sure that we don't reach more than the amount of this middle. And then this temporary will keep track of the sum of our rails, so the sum of the rail lengths. And to do that, we also add the minimum of these two multiplied by I, because the I will be the length of this of all of these boards or all of these rails. Then the total maximum waist that we can get is the sum of the whole board subtracted by our temporary sum. So we'll keep on looping through this until we reach two values where L is equal to R. This means that it's the optimal answer for this problem, and we can print out L or print out R, since they're basically the same thing afterwards when we reach the end.